we're not going to do matrix multiplication. Well, we might get to it at the end of today. But all right, so this is a matrix. So this is, if you look closely, you see it says A11. So I'm just naming where the element would be the number in the matrix, where they occur. And so this means row 1, column 1. Doesn't mean 11. Okay? So this means A12 is the element in row 1, column 2. Okay, so if I said to you, hey, find A35, you would go to row 1, 2, 3 and go over 1, 2, 3, 4, 5. Okay, if you're asked to identify elements. Okay, so we use the shorthand notation Aij. So I is the first thing. Right, I is what row it's in and what column it's in. And so this, and then this is just the element. So if you're looking in a matrix and I ask you to find a number, you should just be able to look at a matrix and tell me what's in that spot. That's all that means. Okay? All right, so the first number when we were talking about matrices, when we say it's an m by n matrix, we do state that we do the rows first and the columns second. Okay, so how many rows it has? So we'd count how many rows it has and how many columns. Okay. All right. Let's just review matrix addition and subtraction. In order to add or subtract matrices, you can't add and subtract every matrix. They would have to have the same dimensions. I hope that makes sense. So if I wanted to add these together, pretty simple, I just add the elements that are in the same spot together. So 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 4 is 7. 4 plus 5 is 9. 5 plus 6 is 11. Okay, does that make sense? Okay. So today, like, I'll give you a worksheet. If I ask you to add or subtract matrices that are not the same dimensions, we would just say that that's undefined. You can't do it. Okay. Over here, we can do scalar. This is called a scalar because you're multiplying by a whole scale. Okay. This means you would multiply the whole matrix by 3. It is. So what would this matrix be? 3, 6, 9, 12, 15, 18. Okay. And then I don't know if I did this, but you can do combinations of that. So if I said 3 times this minus 7 times this, okay, you'd multiply by 3 and 7 and then subtract them or add them or whatever. Okay. So subtraction works the same way as addition. In order to subtract, they would have to have the same dimensions. Okay. Oh, good. Yes, we are going to do matrix multiplication. Cool. So just some vocab. The zero matrix is any matrix that consists of entirely zeros. Okay. So if I asked for the zero matrix that was a 3 by 3 matrix, it would just be 0, 0, 0, 0, 0, 0, 0, 0, 0. This is the 1 by 1 matrix. There is such a thing. 1 row by 1 column. And it is 0. Okay. So an additive inverse. You guys remember back, I don't know, probably in 6th grade maybe?
No, I don't remember.
Where what's the additive inverse of something? Like what's the additive inverse of 7? -7. Because 7 plus -7 gives you 0. And in addition, the identity is 0. It's called an identity because when you add 0 to anything, it doesn't change it, correct? By the way, what's the identity in multiplication? 1, because when you multiply something by 1, it doesn't change it. So we actually call the inverse in multiplication the reciprocal, because like if I had 2/3 times 3/2, I'd get 1. So inverses depend on what operation you're dealing with. So sometimes I'll ask for an inverse and people will say it's the opposite, and I'll say no, it's not. It depends on the operation. Okay. So in matrix or matrices, we have actually, if you flip forward, the identity matrix. And the identity matrix works the same way as the identity of addition and subtraction and multiplication works. If you multiply a matrix by its identity, it should not change the matrix at all. Okay. All right. So let's review matrix multiplication. So in order to do matrix multiplication, and I will ask you to do some small stuff, what we do is we do an entire row by an entire column. And so what happens then is, I'm just going to write this out. If I did row 1 times column 1, what I get is the number or the element that's going to go in 1, 1. All right, so you're not doing 1 times 1 and then putting it somewhere. You're going to do row 1 times column 1. Now, in order to make this work, do you see how there's 3 things in row 1? There has to be 3 things in column 1. Okay? All right, so here we go. We're going to do row 1, column 1. And then I'm going to put it in row 1, column 1 right there. So I do 1 times 1. What comes next? 2 times 2 plus 2 times 2 plus 3 times 0. All right, let's do that. 1 plus 4 plus 0 is 5. And then that goes right here in row 1, column 1 of my new matrix. All right, while we're on row 1, let's do row 1 times column 2. And that's going to go in the 1, 2 spot. All right. So I'm doing 1 times 0 plus 2 times 1 plus 3 times negative 1. Let's see. 0 plus 2 minus 3 is negative 1. Yep. Okay. So now what do I do? Yeah. So now do you see how I did row 1 by each thing and I'm done with row 1? Now I move on to row 2. So row 2 times column 1. Okay. Are you remembering that? Kind of. It's going to be the element in row 2, column 1. All right. So we have 0 times 1 plus 1 times 2 plus negative 1 times 0. And that gives me 2. Not a 4 by 4. How many? 4? There are 4 elements in it, but what are the? Yeah. Okay, so then I'm going to do row 2 times column 2, and I'm going to get the element in 2, 2. So this one is 0 times 0 plus 1 times 1 plus negative 1 times negative. So 0 plus 1 plus 1 is 2. Okay. And so that brings up a good point, Carmen. How do you figure out what the new dimensions are going to be? So I think probably Mr. Staublin taught you this, but what are the dimensions of matrix A? 2 by 3. And what are the dimensions of matrix B? 3 by 2. And so the reason why we could do this multiplication was because these inner things matched. Okay? If I asked you to do B times A, that would also work, only in this case because if I listed this first and that second, the 2's would match. Okay. So when we check to make sure that we match, the outer numbers then become the dimensions of the new matrix. So this is a 2 by 2. So sometimes you can't multiply matrices again by each other. Can you guys give me an example that would work one way but not the other? Let's do some dimensions. 2 by 3 times a 3 by 4. If I did the 2 by 3 first and the 3 by 4 second, that would work. And the result would be a 2 by 4. Okay? But if I switched it around and did 3 by 4 times 2 by 3, do you see that these don't match? You would not be able to do that matrix multiplication. Okay? All right. Let's get through identity. And we'll talk about inverse of a square matrix, but we won't do that quite yet today. All right, so do you kind of remember the identity matrix, the ones on the diagonal? Okay. The n by n, so the reason why I write n by n is this is only true for a square matrix. The square matrix means the same dimension, okay? So a 2 by 2, 3 by 3, 4 by 4, and so on. And they've got all ones on the diagonal and all zeros everywhere else. This is called the identity matrix, okay? So here's the deal. What you need to know about an identity matrix is if you, like I said, if you would multiply a matrix by its identity, then it shouldn't change anything. Okay. Can somebody make up for me a 2 by 2 matrix? 4, let's throw some negatives in there. How about -1? Jeez, Bobby. All right, he wants to do lots of... Okay. What would the identity be for this matrix then? Okay. I just want to we don't have to do all of it out. I'm just going to ask us to do the multiplication in our heads and see what happens. Wouldn't I do 4 times 1, which is 4, plus 0? What's 4 plus 0? 4. Oh, it's the same thing. Okay. 4 times 0 is 0. What's -1 times 1? 0 plus -1 is -1. What -12 times 1 is -12, plus 6 times 0. Okay. See? And if I put the 1, and if I put it in the front, it would work as well. It doesn't matter with an identity where you put it. But it is truly an identity. That's what the definition of that word means for matrix multiplication. Okay? So, here's what you need to know then about the word inverse. I hope this makes sense. If something is an inverse, and I do it to the matrix, I should get the identity back. So, if there would be an inverse, okay, let's say A and B were inverses, I should be able to multiply them together in either way and get the appropriate matrix with a 1 all the way down the diagonal. Okay, so does that make sense when just you're thinking about what an inverse and identity are and other things? So that's that definition. So if I ever say to you, use the, check if these are inverses, use the definition of an inverse, then multiply them together and see if you get the identity. That's a different question than finding the inverse. Okay. But while we're on it, do you have your calculator handy? Okay. If we have time when we get back from spring break, I'll show you how to find an inverse of a 3 by 3 matrix. But you should probably remember this thing, kind of sort of from last year, where you did the A times D minus B times C, and then you did that, and you multiplied it by this. No? Okay. All right, anyways, we'll get to that tomorrow. We'll talk about that tomorrow. But I'm going to go into matrix, just quick a second. Oh, I have one in here. Okay. From last year. Okay, so there's my matrix. It's a 3 by 4. Okay, I'm going to make it a square one, okay? So I'm going to make it a 3 by 3. And I'm going to just put random numbers in there. You guys just watch. You don't have to shoot it. Alright, so here's my 3 by 3 matrix. Okay. So if I wrote down, so that, here I'll do it again, matrix A. So if I did that, then that comes out. If I wanted the inverse, I'd use the inverse key, which is that. Ooh, so there's the inverse, lots of decimals, right? Here's what I want to show you, though. Without taking the time to do the matrix multiplication by hand, when I do matrix A by matrix A inverse, what should I get back? Because it was a 3 by 3. Can somebody tell me? 1 0 0 0 1 0 0 0 1. Okay, and I do, because 1 times 10 to the negative 14 is 0. It's just your calculus. Okay, so that's what it means to be an inverse. When you multiply them together, you get the identity.